In example 2, we're going to use half-angle identities to evaluate the cosine, sine, and tangent of a half-angle. And we're given that the cosine of theta is root 5 over 5, and theta is from 0 to pi over 2 inclusive. And that tells us that theta is in quadrant 1. Our cosine of a half-angle identity is plus or minus the square root of the quantity 1 plus cosine of A divided by 2. And since we're in quadrant 1, we know that half of a quadrant 1 angle still has to be in quadrant 1. So we're going to keep the positive since we're in quadrant 1 and discard the negative. So applying this identity, we're going to have the positive square root of 1 plus the cosine of the angle, and the cosine was given as root 5 over 5. And that is our numerator, and it's being divided by 2. And that's all under the square root. Okay, then we need a common denominator of 5 in order to add these fractions. And that's going to be 5 plus the square root of 5 then in the numerator, all divided by our common denominator of 5. And dividing by 2 is the same as multiplying by 1/2. And so we have the square root of 5 plus the square root of 5 in the numerator, and that's all divided by 10 in the denominator. Okay, and if you don't rationalize the denominator, that would be your solution to the cosine of theta over 2, the half angle. Now, if you do rationalize the denominator, that would add one more step, and we would take our fraction here under the radical, and recall that that fraction under a radical is the same as the square root of the numerator divided by the square root of the denominator. And so to rationalize the denominator, since it's a monomial, we're going to multiply the top and bottom by that same monomial root 10 over root 10. And when you multiply radicals, you multiply the radicand with the radicand. This is a monomial times a binomial, so we would distribute. And 10 times 5 is 50. And then 10 times root 5 would be 10 square root of 5. And then that's all divided by root 10 times root 10, which is 10. And those would be equivalent, only the second form is rationalized. So to check that in the calculator, to make sure we rationalize the denominator correctly, we would evaluate the first expression, which is the square root, and then in the numerator we have the quantity 5 plus the square root of 5. And then that's divided by 10, and we get this decimal approximation. Then in the second rationalized version, we have the square root of the numerator, which is 50, plus 10 square root of 5, and that's all divided by 10. And when you compare those decimals, they're equivalent, so you know that you rationalize the denominator correctly. Okay, in problem 2, we want to find the sine of theta over 2. So now we're using the sine of the half angle identity, and since we're in quadrant 1, again, we're going to keep the positive square root. So this is going to be equal to the square root of 1 minus the cosine, which is the square root of 5 over 5. And that's divided by 2. So now when we get our common denominator, 5 over 5 minus root 5 over 5 is 5 minus the square root of 5, all divided by 5, and then dividing by 2 is the same as multiplying by 1/2. And so in the numerator is 5 minus root 5, and the denominator is 10, and that's all under a square root. So that would be our solution if we do not rationalize the denominator. Again, square root of the fraction is equivalent to the square root of the numerator, 5 minus the square root of 5, divided by the square root of the denominator, that's square root of 10. Then to rationalize the denominator, we would multiply by root 10 over root 10. And distributing that radicand, we'll have 50 minus 10 square root of 5 in the numerator, all divided by our rationalized denominator, which is 10. And you can check that those are equivalent in the graphing calculator like we did in the example above. And then to find the tangent of the half angle, we have 3 identities that we can choose from. We've got plus or minus the square root of the quantity 1 minus cosine of A divided by the quantity 1 plus cosine of A. We've got the sine of A divided by 1 plus the cosine of A. And then 1 minus cosine of A divided by sine of A. Now, we only know the cosine of the angle. We don't know the sine of the angle. We could figure it out using the Pythagorean identity, but since we have a version of the half angle identity for tangent that only involves cosines, that's going to be easier than having to do the Pythagorean identity and then have another version of the half angle identity for tangent. So we're going to go ahead and, since we're in quadrant 1, use the positive square root of the quantity 1 minus the cosine of theta, which is root 5 over 5. And that is divided by 1 plus the cosine of theta, and cosine again is root 5 over 5. So getting a common denominator like we did in the previous examples, 5 over 5 minus root 5 over 5 is going to be 5 minus the square root of 5, all divided by 5. And dividing by a fraction means to multiply by the reciprocal. So we'll have 5 over 5 plus root 5. That's all under the square root. And then we can see that our 5's here cancel. And we have the square root of 5 minus root 5 divided by 5 plus root 5. And that would be the tangent of theta over 2. Okay, to rationalize that denominator, we're going to take the square root of the numerator, which is 5 minus square root of 5, as the radicand, divided by the square root of the denominator, 5 plus root 5. And then we're going to multiply the top and the bottom by that denominator, 5 plus root 5. And so in the numerator, we're going to multiply what's under the radicals together, and that's a difference of squares. So 25 minus 5 is 20, so we have a square root of 20 in the numerator. And in the denominator, the square roots cancel, and we have 5 plus the square root of 5. Then we need to rationalize the denominator a second time, and that's a binomial denominator. So we multiply the top and bottom, by the conjugate, which is 5 minus the square root of 5. And then in the numerator, when we distribute, we're going to have 5 square root of 20. The square root of 20 is 2 root 5, and so that would be a 10 root 5. And then square root of 5 times the square root of 20 is the square root of 100, which is 10. And then in the denominator, we have a difference of squares from that conjugate. 25 minus 5 is 20. And then all three of those terms are divisible by 10. So we'll have a root 5 minus 1 all divided by 2. And we can check this in the calculator that we rationalize the denominator correctly by entering our first solution, which was the square root of the quantity 5 minus square root of 5 divided by the quantity 5 plus the square root of 5. And we're going to compare that decimal to the answer we got when we rationalized the denominator, which was a square root of 5 minus 1 all divided by 2. And we see that our decimals are equivalent, and so our solutions are numerically equivalent.